Okay, let's go through this algebra assessment. Just watch this through, just checking all of your workings, pay particular attention to questions that you didn't get correct, and obviously rewind and do what you need to watch again if you're still unsure about something. So, getting started, we've got question 1, and we have, first thing to notice in this, 6x minus 9 equals 4x. We have an equal sign in there, so there is something to solve. It is an equation because there's an equal sign, and so we're going to manipulate this by doing the same thing to both sides. And we're going to communicate that well throughout. So first thing I want to do is I want to get all my numbers and letters on the same side as each other, so all my letters on one side and my numbers on the other. So the first thing I might do here is subtract 6x. And subtract 6x obviously from this side, so put it in a circle, just communicating what I'm doing. And then my next line needs to read minus 9 equals 10. Subtracting 6x from 4x gives me minus 2x. So from here I've found a value of minus 2x, but I want to know what 1x is worth. So I divide by that coefficient of x, what's in front of it. So now I'm dividing by minus 2 on both sides. And I run out of space, so I'll pop over here, and I get minus 9 over minus 2 equals x. Now minus divided by minus gives me 4.5. And you could have written that as 9 over 2, you would have got the mark. Now, second question is rearranging a formula. So I want to here now rearrange the following to make x the subject. So this works in a very similar way to an equation in terms of our manipulation of it. We just need to get the x on its own because it says we need to make x the subject. So let's get started. First thing I want to clear out is that p. So I need to add p to both sides. So that's what I'm doing. 2xr equals 9 plus p. I can't group them together or anything. Now, next move I want to make to get the x on its own, I need to divide by 2r's. Because there's a 2 and an r that are multiplied by x. So divide by 2r, and the only way that I can write that is x equals 9 plus p over 2r. And there we are, we're done. I'll just erase that a little bit just so I can see the next question. Okay, question 3. Using k equals minus 5 and m equals 4, evaluate k squared brackets 3k plus 2m. Thing to watch here is we have now what's called an expression. We can't manipulate this, we're just going to evaluate it. So we find a value for it with these particular inputs. So there's no doing the same thing to both sides, there's no changing it. It is just that thing, it's that expression. But we can make that substitution of the values that we're given. So we've got, instead of k, minus 5 squared, then 3 times minus 5 plus 2 times 4. And what's that? Well, minus 5 squared is 25. 3 times minus 5 is minus 15 plus 8. So a lot of this question is about knowing how our negatives work. We're essentially getting 25 times minus 7. When you do minus 15 times plus 8 and 25 times 7, we can probably do it in our head, because 4 lots of 25 we know is 100, and we had another 3, 175, but we've got one negative, so the answer is that is equal to 175 minus 175. There we are. Okay, expand and simplify the following. Again, no equal sign. We can't change the value of it, but we can expand these brackets and collect our like terms. So 7 times p, 7 times 2q, minus 3 times p, and minus 3 times minus 2q plus 6q. Careful there. And so I can put together my p's, and I can put together my q's. And if I group them, how many p's do I have? 7 minus 3, 4 p's, and 14 plus 6q is 24. q. Okay, question 5. Rearrange to make x the subject. Right, we have an equals sign again, so we're allowed to do the same thing to both sides and manipulate this in order to get x on its own. First thing I would do, and this one, is clear out this b. So in order to get rid of this from this side, I'm basically unravelling this to get the x on its own if I can. So the b's kind of awkward, it's there in the way. So let's subtract b from both sides. And I get a over x equals c minus b. Okay, the issue I've got now is that this x is on the bottom of this fraction, it's on the denominator, and I don't want it there. I need to get it up high so that it's then going to be the subject of something. If I divide it by a now, it's just going to leave 1 over x, which is going to be tricky. So the next move I'm going to make is to times by x on both sides. Now, what does that leave me with? It leaves me with an a here equals c minus b all times by x. Now, I could have written the x in the front, but it's just important that when I times by x here on this right hand side, it multiplies by the whole of that right hand side. Now, don't fall into the trap of expanding the bracket. It's actually really helpful that it is factorised, which means now the final move I can make is to just divide by c minus b on both sides, divide by c minus b, which leaves me with a over c minus b equals x, and there's our answer. Tell you what I might do, just tidy things up a little bit. Can I do this? Move that up there. This is going quite well actually. Just erase this to give me a bit more space. And you can kind of see how it worked. But it should really follow down. It's not ideal to go across. I'm just saving a bit of paper. Okay, question 6. 12 plus 3a minus 2. Again, expression. There's no equal sign, so I can't manipulate it. We can just expand and just see what the value is. So 12 plus, now 3 times a is 3a, and 3 times minus 2 is minus 6. The only things I can group are the numbers, the 12 and the minus 6, which should leave me with 3a plus 6. 12 minus 6 is positive 6. That was quite a nice quick one. Question 7. Substitution again. To evaluate this, we've got a formula now. So it says use m is 12 and v is minus 7 to find e. It's quite handy in this case that we've got e as the subject of our equation, or subject of our formula, because then we just need to plug everything else in. So what does it look like? We got e is equal to, oh, that's not a very good equal sign, a half of 12 times minus 7 squared. Next thing I would do is half of 12 is 6, and minus 7 squared is 49. Positive. A minus times a minus is a positive. Now 6 lots of 49, I can actually work that out in my head, because I'm going to think, well, what's 6 lots of 50? That would be 300, but I've got one less than that each time, so I just need to do 300 take away 6, and that equals 294. So E, 294. Okay. Oh, that's coming with me. That's not what I wanted. Try and put it back somehow. Leave it there. Go over there. Okay, it's kind of out of my way. That's the best I can do. Okay, now we're dealing with a formula again, and we're not subbing in values now. We're making a different letter the subject, which means we need it to be c equals. And what's happening to the c? Well, it's being squared and it's being multiplied by m in that order. So when we undo it, we have to undo it in the opposite order. So the first thing I'm going to do to this, let's get rid of that, is to divide by m, which leaves me with e over m equals c squared. And the final move to get it c equals is I need to square root both sides. So when I square root both sides, that leaves me with the square root of e over m equals c. Now just be careful that this square root sign covers everything, because it's a very different answer if it just looks like it's covering this e. And I did want you to watch out for that. So that's not what we want. What we want is this square root ensuring it covers both the e and the m. Okay, we're making good progress. Where are we? Question 9. Now, factorise. First thing we need to recognise is that this factorise means that we're putting in a bracket. So we need to put it into a bracket, and we need to spot which letters and which numbers are present in both of the terms. So if I was dealing with just the numbers, the 4 and the 2, I'm going to ask myself, what times table contains both 4 and 2? And what's the biggest times table that contains both 4 and 2? And the answer to that is going to have to be 2. Now I need to look to see if there are any letters in both of my terms. Now, first thing that I come across is that x to the 4. So I'm going to see if there's an x in the second one, and yes, there is. So I need to also have an x. And the next thing I'm coming across is this y squared. So are there any y's in this one? Yes, but there's only one y in this term, whereas this one has 2 multiplied together. So I need to put a y outside, and that should enable me to fully factorise this. So I need to ask myself the question, what does 2xy have to multiply with to make 4xy squared? Well, to go from 2 to 4, it needs to multiply by 2, first of all. I've already got an x, so I don't need to put another x in. But if you spot here, this term has one y more than this one. Again, multiplied together, not numbers of y really, but it needs this 2y. Now, for the second term, I need to ask myself, what does 2xy multiply with to make minus 2xy? That's got to be minus 1. Okay, let's move on. Question 10. Solve 5a over 6 equals a over 3 plus 2. So we need to work out how big a is. Now, I've got 2 fractions, and I want to get rid of fractions if I possibly can. Again, I can manipulate this. It's an equation, it has an equal sign. So I need to think about what I can do to both sides in order to get rid of those fractions. Well, in order to get rid of this one, I could multiply by 3. And in order to get rid of this one, I could multiply by 6. Now that's preferable because the multiplying by 6 will also get rid of this 3. So if I multiply everything by 6, let's see what happens. Times by 6, and times the whole of that right hand side by 6 as well. Well, the left hand side just becomes 5a. A divided by 3 times 6. Now, if you're not sure about this, we could write 6a over 3 and think, well, what's 6 divided by 3? Well, that's 2. So this becomes 2a plus 2. If I subtract 2a from both sides, I get 3a equals... Ooh, big mistake, big mistake, big mistake. I forgot to multiply the whole of this right hand side by 6. So when I multiply 2 by 6, I should get 12. So when I subtract 2a next time, I'm left with just that 12. And from there, I'll just write it out again. If I divide by 3, I should get a equals 4. That's my answer. Okay. We have a double bracket here, which means we need to ensure that we multiply everything in the first bracket by everything in the second bracket. And you may have all sorts of different ways of doing this, which is fine. I'll use a different pen just so we don't get confused. So we need to make sure we multiply everything together. And you might make a smiley face with that. You might not. You might have some other different method. But the process is just making sure that everything in these 2 terms multiply with both of these. It leaves us with 4 terms. So the first thing I'm going to do is the x times the y, which leaves me with xy. Then I'm going to do 3 times the y, 3y. Then I'm going to do x times the minus 7, and 3 times the minus 7 is minus 21. And the only thing I need to do now to finish this off is just to see if any of these terms will collect. Are they any like terms? Are there any y's that can add with other y's, any x's, etc., or numbers that can add together? And in fact there aren't. There are none here, because they're all got different types, different numbers, or different letters that make up each term. So this cannot be simplified at all. That's my final answer. I'm done. Okay, question 12. Similar process. I need to multiply out this double bracket and make sure I multiply everything together. 3 times 2x, 6x. Minus 4y times 2x is minus 8xy. Minus 6 times 3, minus 18. And which one haven't I done? Minus 6 times minus 4y. Ooh, careful, that's positive. Plus 24y. And remember, I have these terms as well. Plus 2x minus 3. Okay, now I need to identify if anything can be collected. Any like terms. So, oh yes, I've got some x's here and another 2x's here. And I've got some numbers here and some numbers here. Let's go a different colour for the numbers. And all I'm going to do is collect those like terms and write out my final answer. So 6x plus another 2x gives me 8x's. Minus 8xy is unaffected. Minus 18 take away another 3 is minus 21. And my 24y is unaffected. And there's my final answer. And there we are, done for our algebra to start us off.